and share the screen. Cool. All right, and now let's get, yeah, so Ajax, that's going to be Monday. Ajax is. HTTP request response is right now. All right, so like I said at Stand Up this morning, this is a really critical topic for web engineers. This is something you are going to be expected to know on any interview for a web engineering type job. You are also going to be expected to know it in your interview for phase 3. So, you know, that overlaps. Okay, so what I'm going to talk about is what actually happens when you enter a URL into your browser. What information gets transferred? When does it get transferred? In what format? That's today's lecture. At Hackbright, we called this lecture How the Web Works. Okay, so the first thing I want to emphasize, well, not emphasize, but just a little bit of vocabulary first. Very simple. You have a client. For the first part of this lecture anyway, the client I'm going to be talking about is your browser. And your browser creates an HTTP request. That's the first thing that happens. Then the server receives the request and creates an HTTP response, sends it back to your browser. Server receives requests and creates responses. Browser receives responses and creates requests. Or client, like I say, it can be something other than a browser. So let's talk about requests first. There are a lot of different parts to the request. So, by the way, the way these lectures are structured, like orange means like big topic, and then green means small breakdown of the big topic. So part of a request is the URL. There's one piece of the request. The URL itself has lots of different parts. The first thing is the scheme. Sometimes this is also called protocol. It can be HTTP. It can be HTTPS. What's HTTPS? Secure. It can be FTP. It can be a lot of different protocols, but when we're dealing with web, it's often HTTP or HTTPS. Then the subdomain, domain, and top-level domain, I'm not so interested in separating. I just got this off the web and it had pretty colors. So this really is the server. 2, 3, and 4, that's the server. Then you get a colon. After the colon, you get the port. The port, usually you guys don't put a port, right? You do not type in www.google.com:80. If you don't put in a port, it will default to port 80 for HTTP or port 443 for HTTPS. What is a port?
Place in the hardware through which it accepts communicates with external world.
Yeah, so Mira said it's like a place in the hardware through which you communicate with the external world. Yeah, it is sort of like a channel on which you're listening for requests. So if I specify port 3000 here, I say I want to direct this request to the channel listening on 3000. Express servers, I think by default, listen on 3000, or at least by convention, listen on 3000. You leave it off, it directs it, if it's HTTP, it directs it to whatever's listening on port 80. Or if it's HTTPS, it directs it to whatever is listening on port 443. All right, the path. So here, after the port, you are going to put some slashes, right? And that's called the path. That's what resource you're asking for on the server. In the old days of the internet, this had to be an actual physical file on the server, right? There had to be a file at that location. Or if you did a directory, it would serve whatever file was at index.html. Do you know the reasoning behind that index.html? Like what the index means? So originally, when you went to a directory in HTTP, if there was no index.html, it would just show you all of the contents. It would give you an index of the directory. That's if there was no file called index.html in there. And so people started to put an index.html in there to give a nicer version of the contents of the directory. And then index.html became something entirely different. It's just whatever they wanted to show if somebody entered that path. And also now in modern web programming, I started web programming in like 1996, 1995. So the things were much different then. In modern web programming, you can also put variables in the path, right? Have you guys done that with Express, where you can say path resource and then you could put a 1, and Express will grab that 1 and use it as a variable. So this doesn't refer to a location at all anymore. It really used to. It used to really be like the path from whatever your route was. All right, then you have your question mark, and after the question mark becomes the query string. The query string is key value pairs separated by an ampersand. And those are going to be, whatever is receiving the request will have access to those as part of the query. And then some of you have seen this fragment identifier. The pound just tells you where on the page to go if there are anchors on the page. All right, so URL, part of the request. It has a ton of information, or potentially has a ton of information in it. Questions on this? So when you type your the address into the browser, www.example.com is not an actual location of a server on the internet. Servers are located on the internet by IP address. You guys might have seen that. It's like 131.106.110.12. It's a series of 4 numbers separated with dots, and they go from 0 to 255. DNS is fascinating, and I am not going to talk about it really now. But basically, it's decentralized. You have many, many, many named servers out there, and your browser goes out and says, it just sort of asks the internet at large, what is the address for this, or what is the address for this name? And the server that's responsible for it will get back to you. There's a webcomic that I recommend to people and have never read because my interest in DNS is not very deep. But if yours is, I advise you to look more into it, this webcomic. I hear good things about it. What's that? There's a link, and I will send these slides out. So yeah. Right, okay, so you type in your URL. Your URL has a ton of information in it. DNS takes that server, the thing between the protocol and the port, and translates it into an IP address so it knows where to send your request. Let's talk about HTTP methods. It can also be called HTTP verbs. You guys have probably seen these before. So get, and so basically this is telling, this is part of the request as well. So the request has the URL, DNS is a little sideline there. The request has the URL with all that information, and it has an HTTP method. And the server will deal with these differently depending on the method. The server is listening for particular methods at particular routes. If you guys have written your Express servers, you know you do like an app.get for this route. That means I'm listening for GET requests at this route. You do an app.post at the same or a different route. I'm listening for post requests at that route. So this is convention that you use GET if you're just asking for data. So if I want a list of pets on the server, I can just make a GET request. By default, when you type in a URL in your browser, it's making a GET request. Post requests, that's more for submitting a form or making a new, let's say in this case, a new pet. So if I'm going to do a post request, I can't do a post request from the browser. We'll talk later about how I can do a post request, but sometimes the page is written so that if you submit a form, it submits it via post. But I can't do a post request just by entering a URL in the browser. Then there's put. Put is often used to edit an existing, let's say pet in this case. And put is idempotent. This is the difference between put and post. That means if you send the exact same request, it should have exactly the same effect. This is not anything that's enforced, it's just conventional. So that means if you have a request that is going to be incrementing a pet's age or increment, let's say it's going to be, oh God, now I can't even think of anything. So let's say you have a post that is going to be, let's just say incrementing a pet's age for one, so you have a button on your page that says add 1 year to my pet. You would do that with a post because it's making a change on the server. You wouldn't do it with a GET. Anything that's making a change to the database, again, by convention, should be done with a post. But that should not be done with a put, because if you do that post once, then the pet is going to end up with an age 3. Let's say if they started with age 2. If you do that again, they're going to end up with an age 4. If you do that again, they're going to end up with an age 5. Different results if you do it different times. Put, by convention, the database should be in exactly the same state no matter how many times you submit the request. Idempotent. Actually, I've only read that word, so it might be pronounced idempotent. I have no idea. This is like when I was in the 3rd grade and somebody asked me, how do you pronounce Political? And I'm like, well, political, okay. And then delete is if you want to say remove a pet. I have a lot of links to the official reference for these things. There are some other HTTP verbs, but these are the most commonly used. All right, so your request, it has a URL with all that information and it has a method. It also has headers and a body. So the headers are just a set of key value pairs. And so example keys, it is always going to have the date. It might give you the content type of the body. If you're sending a body, we'll talk about the body in a minute. It has things like accept language. What kind of language? I'm going to tell you as the server that you can respond to me in English and Greek, but nothing else. There are a lot of them. we go to the Wikipedia list, so here are request fields, right? So these are all the possible keys you can have for request headers. A lot of different things you can use to communicate with the server. Oh, poor Aisha. Let's see. All right. Is this like when one refreshes during a credit card transaction and you end up with multiple? Oh, yes. Yes. Sort of. Oh, I guess I don't need to type. You can hear me. Yeah. So one difference between get and post, and this isn't exactly your question, but I'm glad you asked it because I want to say this. You know how sometimes when you refresh a page, it'll just refresh it, and sometimes it asks you if you want to submit data again. When you're just refreshing the page, that means that the page was received via get. And if it asks you if you want to submit the data again, that means it was post or put or delete. So that's just something, and so that's used, I'm looking at the microphone like I'm looking at Aisha. That's just used to make sure that people don't submit something again by just refreshing the page, or they don't, like, let's say you submitted an Amazon order and you're like, and you want to forward the confirmation page to your mom, and so you take the confirmation page and you forward it to your mom, and if just by loading that it submitted another order, that would be terrible, right? So you want post, you definitely want anything that has side effects on the server, you want to use post for. Okay, all right, we're good. Okay. Okay, so let's go back. Right, so those are all of the headers. So those are all request headers. And request headers are different from response headers, and we'll talk about that in a minute. So let's see, all right. Okay, so we've got the URL, we've got the verb or the method, and we've got the headers. And the headers include cookies. I'm going to talk more about cookies when we talk about the response, but in the request, you are going to look and see whether any cookie belongs with this request. And whether or not a cookie belongs with the request depends on the server and the path, the server and the resource. I'm sort of using resource and path interchangeably. So if you have a cookie on your browser that is associated with this particular server and path, and it hasn't expired, and other conditions, then that cookie will be sent along as the value for the cookie header. How did the cookie get there? Well, we'll talk about that in the response section. The server put it there, and we'll talk about how it does it in the response section. Okay, so far, what's part of the request? A verb. What's an example verb? Get. Okay. What else is part of the request? Headers. Example header. Date. Okay. The URL. What are some pieces of the URL?
Query string, fragment identifier.
The query string, the fragment identifier. Yes. What else? The protocol.
Domains.
The domain, or really the server name. Yeah. How does a server name get translated to an IP address? DNS. Let's see. I think there's at least one part of the URL we haven't talked about yet. The port. Yeah. Where you want to direct this request on the server. Okay, and then the body. For GET requests, all of the data is in the query string. GET requests don't have a body. But for post and put and delete requests don't need a body. You're basically just deleting the resource that is wherever the path is specifying. But for post and put, you can include data in the body. You can also include data in the query string. It's conventional to include it in the body. Yeah, Misha.
June. When we did the live app with Justin, post is the only one that can have a body, but can't have a body. That's why I had the understanding.
I believe that is not true.
Okay.
Yeah, we can go back and revisit that later.
Okay. Yeah, I thought I just watched that.
Okay, yeah, let's talk about it later, but right now I'm going to dig my heels in and say that's not true. Yeah.
I think it was that they both have bodies, but one of them you have to submit everything and send it back, and the other one you can just submit change.
What you want to change?
Yeah.
So one of them, if you're creating a new something, or no, actually, I mean, put, because of the idempotency, put, you probably do want to submit everything just to make sure that every time you do it, okay, there we go. All right.
Yeah, because I remember when we did it, we had used your name, and when we did it as a put, it's like if we added your last name, it would erase everything else.
Right.
But when
Yes.
we did it in a post, it was like, oh, just change this one thing. It's like, okay. So that both is considered a body, but
Both is considered a body.
how you're implementing the. Okay, got it.
Yeah, because the body is any data that you're sending that's not part of the query string, and that's not part of the headers, right? That's the body. And so the body in general looks like a query string. So you have key value pairs separated by ampersands. Unless you specify in the headers that it's going to be something else. You can specify in your request headers that the body is going to be, say, JSON. And then the body wouldn't look like a query string. It would look like JSON. Okay, let's see whether we have anything else. Oh, we do. All right. Great job. Okay. She said DNS. I think she was responding to a question I asked a long time ago. Or they. Sorry, Aisha, you're a they. My apologies. Okay. So. Okay. So right. So now we've got the body. In addition to the headers, the URL, and the verb. Or method, verb or method. Okay, so we were talking about all of this as putting it into the browser, but I said that you couldn't make a post request from the browser, right? Basically, all you can do if you're putting something in the URL line of the browser, it's going to be get. So if we want to make post requests or put requests or delete requests, there are other clients we can use. One of them is curl. That's a command line request generator on OS 10. Linux uses wget. I'm sure Windows uses something too, but I am supremely uninterested in Windows at this time. Postman. Have you guys used Postman? Yeah, Postman. Yeah, Postman is a great way to make requests if you're a GUI type of person. From JavaScript, in Node, you can make requests. You can use these different modules. You can use HTTP, you can use request, you can use Node fetch. There are probably other modules you can use to make requests from Node. Send a request to a server, get the response back. What did you say? Request promise. Okay, great, yeah. You can make AJAX requests from the browser. AJAX requests are not you typing something into the URL, but instead you clicking a button or you taking some sort of action, and then the JavaScript on the browser is sending the request. It's not you putting it in the URL and sending the request, but the JavaScript on the browser is sending the request. It doesn't even have to be a response to something. You could even just say like, when the page loads, I want to grab this data from the server. So I have a tools section toward the end of this lecture, and I'll talk about curl and postman in the tools section. All right, I'll pause for questions. Yeah.
Requests always to a server.
Are requests always to a server? Yes. What, did you have an idea of where they might not be to a server? Okay.
So an AJAX request happens on the client.
AJAX request and any request happens on the client side. No, well,
So AJAX takes place on the
AJAX takes place on the client. Now, I was like, any request happens on the client side, but no, if your server is making a request, it is acting like a client in that case. If you are making a request from Node, even if it's on a server, that server is serving the role of a client because it's making a request. Trippy.
mine's kind of blown.
Right, yeah, I might have to see that. Like, no, for real, like, I believe
Well, let's think about it. If you are if let's say everybody's favorite, the movie client benchmark, and so and so you are using HTTP, I think, in that benchmark to get some data from IMDb. In that case, your node script is the client. It is the one making the request. The IMDb server is the server. It is the one generating the response. Let's see how we're doing here. Okay, so all right, so that was all request. So let's move on to response. All right, so the pieces of the response. One is the status code. Indicates the status of the response. And it is a 3-digit number. If it starts with a 1, that means information. A 2, that means success. So 200 is the standard success status code. Starts with a 3, it's been redirected. Starts with a 4, it's a client error. So you often see like 404, file not found. Was it here that somebody posted in random that there was like an apartment number 404 and somebody kept on putting apartment not found? Oh, nerds and their humor. I love them. All right. And then 5 is a server error. So that happens if you make a request to the server and the node script crashes, which I'm sure has never happened to any of you. More official documentation on status codes. Responses have headers too. So responses have a status code and they have headers. The headers are key value pairs, just like the request headers. Some of them are the same, like date and content type. Some of them are different, like expires, for example. There's something that a server needs to tell a client that a client would never need to tell the server, and vice versa. But there's some overlap. All right, so I have a link to the same Wikipedia page if you want to look at response headers. Which ones have you used? Have you guys used response headers? Content type. Okay, so you want to warn the client that what I'm sending you should be interpreted as JSON, or it should be interpreted as an image, or it should be interpreted as HTML. The cookies are also sent in the HTTP headers. So in the response headers. And so there's a set cookie header. And the value is going to include when the cookie needs to be included in the request. And it's things like include it whenever you're sending a request to the server. Whenever you're sending a request to the server, I want you to send me the cookie. Or it can just be whenever you're sending a request to this server at this particular resource. Or if the path starts with this, send the cookie. It also talks about when the cookie expires. So cookies, maybe expire after a month, or maybe you just want it to expire after the current session is over when somebody closes the browser. And then the data in the cookie. So cookies are how Amazon knows that it's you when you come back. When you visited Amazon, when it sent you the data, when you typed Amazon.com, when it sent you the data, it sent a cookie to identify you as being you. And then every time you visit again, that cookie gets sent back to Amazon, so it knows who you are. That's how Amazon can know who you are without you having to submit a form or give it any data in the URL. Amazon knows because it has placed a cookie on your client, and it's asked for you to send that cookie back whenever you send any request.
So, when a website asks you, like, you have a little checkbox that says "Remember me," what it's doing is setting a cookie.
Yeah. So Allie asked, when a website has a checkbox that says "Remember me," is it setting a cookie? And the answer is yes. Yeah. Otherwise, HTTP is stateless, which means that it has no idea what your history is when you send a request unless you include this cookie. Otherwise, I send a request, you send a request, somebody else sends a request from their computers. The server does not know any requests that you have sent before. It does not know what your previous browsing history is. It does not know what you have purchased so that it can recommend that you buy more My Little Ponies, whatever. Yeah.
So is this where the whole idea of tracking state comes from? You hear about tracking state?
Yes.
Because HTTP is stateless.
The HTTP is stateless. So if you want to have a history of the client's previous interactions with you as a server, you're going to have to keep that history. You're going to have to record it. And to identify the client, you have that cookie. And the cookie can have all sorts of things in it. Like the cookie can have not just what your username is on Amazon, but it can have the date you last visited Amazon, right? So that it can say, welcome back, like we haven't seen you in 4 days. Or, and then often nowadays, again, this is more modern web programming as opposed to like back in the early days of web programming. You generally just have you generally have your web framework take care of the cookies. You don't set individual cookies yourself. Generally, the web framework takes care of the cookies, and you just use the web framework's session. And then, yeah, and so it's like abstracted a little bit from the cookies. I've never used Express's session. I've used Flask's session in Python, so I don't know the details of Express's session, but I'm assuming it works very similar to Flask's. Okay, other questions on cookies?
Is this how they used to do a lot of hacking back in the day?
What do you mean?
Like hack that, I remember, like a lot of people used to block cookies back in the day.
Yeah, well, yeah, if you want to block, if you don't want them to know who you are, you can block cookies. But I mean, there's sort of the reverse in that you need, like, if I wanted to convince somebody that, like, for example, I had already logged in, often that's tracked with, always that's tracked with a cookie. They can't tell from just a request whether or not you've logged in, right? That has to be tracked with a cookie. And So you want to make sure that people can't fake a cookie that looks like, that makes it look like you've logged in, that they can't like create a cookie on their machine that just gives the impression that you've actually logged in. That's another thing that at least Flask's session provides is cookie security. It encrypts the cookie. The body. So requests have a body, responses have a body too. The body is always a string. Even if it's an image, it's a string of bytes. If it's JSON, it's a string of JSON. HTML, string of HTML. This is true for the request body as well. The body is always a string. And then if it's an image, say, then you give it a content type so the server knows how to, or so the client knows how to deal with it. And it might contain references to other resources like CSS or JavaScript or images. And the browser is, or the client is going to make a separate request for each resource. So it's going to make a whole new request with all of its URL and headers and everything for every resource that you've referenced on your page. And we can look and see what that looks like. Oh, actually, when I talk about tools later, we'll look and see what that looks like. Oh, look, time to talk about tools. Okay. So the first tool I want to talk about is curl. So curl, it's an OS 10 command line utility. And here I am going to, let's see. Oh, and I haven't checked in with Aisha lately. Not all cookies are opt-in and they're tied to a user's IP address. Correct? Right, you can hear me. Yes, not all cookies are opt-in. Unless you are explicitly, like, you can definitely, the server can put a cookie on your browser at any time unless you've configured your browser to block cookies. And they are not tied to your IP address. They are tied to your browser or whatever client you're using. So if I'm logged in from Chrome and I make a request from Firefox, that cookie is not going to be there. I am not going to be logged in. Tied to the browser.
Hello? Hello?
Yes, was that you, Aisha?
Yeah, that's me. I was wondering if you could hear me. It might be a little faster. So it's not tied to the IP address, it's tied to the browser. But I mean, I guess what I'm thinking of is like, assuming I wasn't logged in, or say I was logged in, it tells the difference between, say, me logging in on my laptop and, say, logging in on someone else's laptop.
Yes, yes. So it's always going to be, so let's do a little experiment. So here in Chrome, I don't know if I've gone to Amazon with this account. I probably haven't. So I'm going to go to Amazon.com. And it does not know who I am. It doesn't say hello, Bonnie. It says hello, sign in. So I am going to sign in. And I'm just going to use my, it's here. Okay. So now that I've signed in, the cookie is here and it says hello, Bonnie. I don't know if you can see that. But,
I can see it.
Okay.
There's the, yeah.
Well, no, that's not a cookie. That's actually a feature of Chrome. Chrome stores passwords for you.
Oh,
Okay, so here I am, hello, Bonnie. But if I open Safari now and I go to Amazon, not hello, Bonnie, it's hello, sign in.
Oh, interesting.
So same computer, different browser.
Same computer, different browser.
Oh.
Because, I mean, if I want to see the cookie, I actually have to go into Chrome. What's that? I've been recently listening. Yes, recently listening to Hamilton. Yes, absolutely right. Okay. So let's see. This actually is not giving me. So I want to go into probably in my dev tools. Do you know offhand, Justin, how to get to cookies from Chrome?
Yeah.
Is it like security?
I said yeah, and the answer is actually no.
Okay.
I mean, it's like.
Yeah. All right.
Somebody said application.
Application. Oh, wait, hold on. Probably not close it. There's an application here. Application. Okay, cool. Okay. And so now we look at the storage, and if we look at local storage, there's the cookie right there.
Oh, okay.
It's the Amazon cookie. Look, I have add double click cookies. That's how they know that you looked at that pair of shoes on another site, and then they keep showing you that goddamn pair of shoes.
That's hilarious.
Okay, yeah. All right, good.
Awesome. Thank you.
You're welcome. Oh, actually, so I take it back. Sorry, that's some local storage. It's a little different from cookies. Here are the actual cookies. You can tell because there's a bite out of it. Yeah.
Okay.
Add double click. Yeah. So if I delete this cookie, you can clear it. And so now I no longer have that cookie. I wonder if I can, I don't know. It sounds like I can't actually delete it, but if I do this, then it doesn't know about my shoes anymore until the next time I, look at shoes.
So it's like cookies. You can't live with them, and you can't live with them.
Exactly. They're not that good for you, but you just can't stop. You just can't quit the cookies.
Right. Yeah. And this controls a lot of the saving you time when, say, for instance, around the holidays, shopping and stuff like that.
Yeah, totally. Or every time I go to Amazon, I do not have to log in.
Yeah.
Right? It knows, it remembers. And it remembers that I buy a lot of supplements that my acupuncturist recommends.
Hey, I use that Great Lakes.
Yeah.
Well, thanks a lot.
Yeah, no worries. Okay. So, okay. So let's see. Oh, and I didn't repeat all of those questions. I'm sorry. Sorry for you people watching along at home. All right. So back to Curl. So Curl is a client. And basically, I can do this, and it gathers whatever I asked it for, and I just redirect to this file. So now if I boogie.json, so this is the body of the response that I got back. And you can, with curl, there are other options. Goodness, okay. All right, fine, there are other options. So you can, for example, you can pass headers. There are other ways that you can get it to show you the headers. So, curl, and let me, okay. Apparently I've completely forgotten how to use spectacle. Okay, good. So that can double as a client. You can also post using curl. So here now I'm curling, and this JSON placeholder was just a place that I found that I could post to, and it would give me stuff back. So I'm giving it the URL, and this is a request, and I'm also giving it the body. The body I'm doing -D, probably for data. So I'm giving it both a URL. I'm not using a port, but this is HTTPS. Does anybody remember the port that HTTPS will default to? 443. HTTP will default to 80. So it's going to default there. And the resource that I'm giving it is posts. And here I'm just giving it this data. My title is going to be curl demo. My body is going to be demoing post, and my user ID is going to be 1. This is like, it's sort of a place where you can send fake posts. So I can do this. And now it's sent me back this JSON. If I want the headers, I don't remember. Include protocol headers in the output. So -I. Let's just do this again, and we'll do a -I. So now we got all of the headers. These are all of the response headers. So including that the content type is application JSON. Oh yeah, and so that curl -- help, you can actually set cookies. So I was just showing the headers in the response, but you can set headers in the for your request. You can set cookies for your request. You can say, I want to make this request and I want to send this cookie, just like the browser would automatically send a cookie. And there's a ton you can do with curl. So -- help. If you're a command line type of person, curl is great. If you are more of a GUI type of person, Postman is great. So Postman, just remember that the request is on the top and the response is on the bottom. So let's take a look at Postman here. All right, so I can post. So I can choose my verb here. There are a lot of them. But you know, generally, okay, so let's do a get. And if I do the get, I'll just use this same one that I used before, this iTunes search. And I can just send it. And here's the response. And this is my response body. I can see what my response headers are. I can see what my response status is. Sorry if this is a little hard for you to read. And then it gives you some stuff like time and so forth. Any cookies came with that response? No, no cookies came with that response. I can also, now if I didn't want to do this term equals boogie in the query string, notice it sent a header of JSON. I think that was leftover. I don't want it to send that header. So let's just not send that header. Oh, and notice that if it's not JSON, I can't do a body, but I can do params. And be careful about this in Postman, because it might feel like I'm making a body here, but I'm not. I'm really just adding to the query string. This is when I hit params. If I want, and so if I went to post and I had that same key value, that is not the body of the post. That's just adding to the query string in post. Instead, I can say, okay, my body, this is what I have for my body here, but I can say, let's see, so now I don't want to post to this. I want to post to my other thing because I don't think iTunes accepts post requests. It has to be something that is listening for post requests. So we'll do this one, and let's see, it has a title, a body, and a user ID. So here's the post, and I'm not going to put my body stuff here with the params. I'm just going to hide that params. But in my body here, now I'm going to just do it, and I'm not going to do it as JSON. Just going to do it as text. And so my body is going to be title equals my title. And this has to be URL encoded. So I can do a %20. I don't know if you guys have done a lot with URL encoding. Title. And body equals my post. And user ID equals 1. So now I can send this. And I can see the response. My response that I got was that the ID is 101. Fine. I can also change this if I want to send JSON. Now I have a header. Now my header is that I'm sending JSON. And my body now, it's warning me. It's like this, this is not JSON. I think that's what that is. And JSON, as you know, is very picky. It needs double quotes. But you don't have to URL encode it. Separated by new lines instead of ampersands. If you're using a number, you don't have to quote it. Okay, now it's happy. And now I can send this and I get a different kind of response. All right, questions on Postman?
So as far as cookies, like how do cookies work? If let's say you're logged in somewhere, is it the same? It's like its own browser, or does it won't?
Yeah, Postman is an entirely separate client. It doesn't consult any of your browsers for cookies. I imagine there is a way to attach cookies to your request in Postman, but I've never done it in Postman. But Google, I'm sure, would be happy to answer that question for you. Okay, other Postman questions? Okay, let's, yeah. URL encoding. So there are some characters that are confusing for URLs. So for example, if, let's see, okay. So random, do the name cookies have anything to do with leaving crumbs? Maybe. I don't know. That's a good question. I'm not sure how the name cookie came about. But I like it. Okay, so sorry to interrupt. I was just fascinated by that question. So fascinated that I forgot what your question was, Sabrina. I'm sorry again.
So I noticed in Postman there's a button you can press.
Oh, the URL encode. Yeah. So what is URL encoding? Let's go back to Postman. So here we can do this form URL encoded. And what this will do, I think if I say, so let's take off this header. Oh no, actually, okay, so it gave me the header form URL encoded. So that's warning the server that it needs to unencode. So now if I say title and I give it a value, my long title with bad characters, question mark / colon, question mark / colon number, you saw in the URL, those are keys. That question mark means something very specific in the URL. So does the ampersand. And you can't include those as part of your data because it will confuse the URL, right? If you put like a / in there, it's going to be like, oh, heading somewhere else to, heading to another part of the route. Or if you put a question mark, it's like, I'm expecting a query string, right? So, and let me see whether it actually, no, it doesn't actually URL encode it for me here. They all have little codes. And I know I just memorized that a space is %20. I think a colon is %2f. There are ways you can look it up, and there are lots of tools on the web where you can put in text and it'll convert it to you for URL encoded. But basically, it's just making your data safe to put in a URL. And so now if I send this, yeah, so it decoded, it got encoded in the body, but Postman just isn't giving you, like, isn't showing you what it got encoded and then decoded. Yeah, Postman is trying to protect you from such mundane details. Okay, so let's just for a minute talk about Chrome tools, Chrome Dev Tools. So I use Command-Shift-J. That will get you to the JavaScript console. Command-Shift-I gets you to the inspector. So we have Command-Shift-J here. And one of the most useful ones here is network. Now, network will not show you anything, and I'm actually more interested in this than I am in Amazon, so I'm going to do this. It actually reloaded some images when I did that because of probably responsiveness. That's really interesting. But in general, you have to have the dev tools open to network and then refresh the page, and then it will show you everything that it's loading. So you remember when I said, if the response contains references to other resources, the browser will make new requests. So look at all of these new requests that it made for all of these resources that Amazon's response contained. Crazy, right? It's still going. So this was my first one. It was Amazon.com, and then we had a query string, and it said ref equals nav sign in. And that's the original one. And it had a status of 200, and it was a type of document, and it was a size of 532. And then everything after that were resources that were embedded in whatever I received from that. And it's like, okay, got to get this resource, got to get this resource, got to get this resource, got to get, it kept the browser very busy. If you double click on it, not like that. If you double click on it here, it will give you more information, including the headers for that particular response. And then it actually also gives you the request headers for that particular transaction. And it gives you query string parameters. So Chrome DevTools, really great. And yeah, network in particular when you're thinking about HTTP request response. Okay. What is a request? What is a request?
Something that we send to the server. Client sends to the server.
Something that a client sends to the server. It's a message from the client to the server. What does a request include? A URL that has all sorts of stuff in it. A verb or a method. A body. And particularly post and put requests is where you put your data in the body. Headers. Headers have things like cookies and also things like the date and other information, what type of browser it is, that type of thing. Okay, what is a response? What the server sends back. And what does a response have?
Status code.
Response has a status code. If you see a status code that starts with 4, are you happy or sad? Sad. 4 is an error. What about one that starts with 2? Happy. Yeah, it's okay. What about one that starts with 3?
It's also okay.
3 is a redirect. You're pretty neutral. You're like, as long as where you redirected me ended up with a 200, I'm good. It's like delaying your happiness or sadness. Okay. Right. So the response had a status code. What else does a response have? Response also has a body. Cookies are included in what? the headers. Yeah, you knew it wasn't the status code, so there you go. Yeah, cookies are included in the headers. Okay, oh, we're doing pretty good as far as time goes, so let me just finish up. Okay, so in summary, just because I like to visualize these things, this is a little bit more complicated than the diagram we had at the beginning. So the client types in a URL, and the client could be a laptop, it could be a mobile phone, it could be curl, it could be Postman, it could be your Node script. And there is a verb, and it also gives the version. There's the host, or what I've been calling the server. And then it's got some headers and so forth. And this one happens to be sending an empty body. And then this one comes back, and it's got the version, the status code, the status message, some headers, and then it's got a blank line in the body. And this is really literal. Like those, it's not sent as a JavaScript object. It is not, where you can like look at which part is the headers and which part. It is sent as a file. It is sent as a string, and the string looks exactly like this. A request is all a string. A response is all a string. Yeah.
This is random. What does connection keep alive mean? I've seen that.
What does connection keep alive mean? I actually don't know. We can look it up, but I actually don't know what connection keep alive means. My guess is that it means to keep the connection alive until the data has completed sending, but I actually don't really know. Other questions? Let's make sure Aisha gets a question. She has one? All right, cool. So if you can answer this, oh, thanks, Aisha. If you